Okay, we're going to cover the ACT reading passage, natural science, not dead yet. So natural science is always passage 4, the last passage in the collection of reading passages, and it's on the far end of the spectrum for reference. Most of the questions are just referring to what it says in the passage, where prose fiction is the other side, which falls under that inference umbrella. But the good thing about natural science is there's multiple strategies to approach the passage. You, of course, can do straight up read and answer, read the passage, answer the questions. It's what I would do if you had unlimited time, for sure. You go summary and answer, whereas you're reading at a faster pace than you're comfortable with. So you're summarizing what you just read with 1 to 3 words, or you are have trouble remembering what you read, so you're summarizing. And mapping and answering is a strategy that works on natural science and sometimes social science also. And that's really just reading the topic sentence and target sentences. So this is the passage we're covering, not dead yet. A dying star is caught flaring briefly back to life. So you get an idea of what it's about just by reading the title. So if you haven't read this one, please take it and read it. We're going to go through how mapping works, mapping and answering, right? This is a strategy that's a shortcut to pick up time, or if you get to the end of the test and just don't have enough time. So I'm just going to read through it. I know this will be kind of boring to watch, but it is what it is. So read the title, not dead yet. A dying star is caught flaring back to life. You're going to read the first and last sentence of the first paragraph. After a billion years before the sun-like star dies or stops generating energy via nuclear fission, it becomes a red giant, growing dramatically to 100 times its original diameter. The white dwarf usually radiates its leftover heat into space for billions of years, and it slowly fades to black. Okay, some soon-to-be white dwarfs, however, seem to heed the counsel of poet Dylan Thomas. Do not go into that, gentle into that good night. This is a target sentence, right? Because it's leading to something else. It's not really the topic sentence. You get the idea it's probably about a star not wanting to die. But according to the theory of stellar evolution, the temperature in the stellar core can fluctuate wildly and sometimes spike as high as 10 millions of degrees. Okay, so it's going to fluctuate. It's spiking. The temperature is going back up. Okay. Alas, such a giant can't last long because the core is, in essence, running on fumes. The star FG Sagittae, a highly variable star in the constellation I don't know how to say that, seems to be a case in point. FG Sagittae lies at the heart of a planetary nebula called HE 1-5. Okay. A research team led by Robert Gertz of the University of Minneapolis has now done just that. Okay, because it said just that, this is a target sentence saying, well, let's look back at what they just did. To see through the haze and examine the goings-on near the star's surface, astronomers must now look at its radiation in less obscured wavelengths, such as infrared light. Sooner rather than later, the current burst of new nuclear fission will cease, and the dusty stellar wind will cease. I'm going to read the last sentence also. Maybe the astronomers of 24th or 25th century will look toward FG Sagittae and see in its surroundings the potential makings of a new and distant Earth. Okay, step 2, possibly something you want to do, maybe not. It's something you got to figure out as your personal strategy, is to map the questions. And this just means putting them as best you can in order they appear in the passage. You want to do this quickly. So number 31, the difference between a sun-like star and a dying star. I remember reading that at the beginning, right? So here we are, 31. Put a 31 there. 32, main purpose of the first paragraph. So we're at a 32 beside the first paragraph. Lines 15 to 16, put a 33 there. According to the passage, one reason the brightness has appeared to change, and when I skim, I see brightness right up here, right? So I'm going to put 34 right there. I'm not sure that's the right place, but I skimmed it quickly and found that. According to the passage, compared to the temperature of the star undergoing nuclear fission, the temperature from Sagittae is, okay, I remember reading about temperature over here where it said it can spike to 1 million degrees, so put it there. Gertz team, all right, Gertz, we read down here, the research team around line 50. Efforts to restart nuclear fission. Okay, I remember reading that up around that third paragraph. And then infrared light, we looked at, I think, infrared light right around that target sentence, around 38. Yeah, they must look at this through infrared lights. Yep. The end of the passage, well, that's easy. We're going on here. And 40, if theoretical models are accurate, the stellar renaissance will last for a period best described as, and I'm going to put up here where it says it can't last long, right? As that was that target sentence there. So we would answer them in this order if we were doing pure mapping. Or you might not want to do pure mapping and just map the passage and go to the questions. Remember, another strategy is Google Summary and Answer. So Google Summary is when you're going to briefly describe what you read in each paragraph. So here's my passage as it's mapped and Google Summary. So I have star phases, temp life, short gas, an example, research, and then death and rebirth. That's my Google Summary. So now we're going to go straight to the questions. And I'm not going to do them in the order I mapped them. I'm just going to do them in order. I generally don't map, but I like students to have that strategy so that if you are running short on time, you have something you could use to shortcut the passage. So the passage indicates that one difference between a sun-like star and a dying star. So we mapped that up here, right, number 31. And that passage says about 1 billion years before a sun-like star dies or stops generating energy via nuclear energy, it becomes a red giant growing dramatically to 100 times its original diameter. So it stops generating energy via nuclear fission, and that is choice A, right? A sun-like star has more fuel for nuclear fission. It's kind of not an odd phrasing, but you got to think about that phrasing. So choice A. 32, the main purpose of the first paragraph. Okay, so first paragraph over here, I Google Summary, that is star phases. And the paragraph is it's a red giant, then it's this, then it becomes a white dwarf, and then it fades to black. So all it's doing is explaining the dying process, explaining the star's phases. So H. 33, the author quotes a Dylan Thomas line in lines 15 to 16, right? So that's here. 15 to 16, do not go gentle into that good night. And then it says, for a little while at least, the core may even flicker back to life. So it's a way of just saying some stars flare back to life. That's the theme of that quote. And if you know that quote, the whole poem is about, don't face death easily, rail against the dying of the light. So anyway, 34. According to the passage, one reason the brightness is appeared to change radically from year to year is, okay, I mapped that up here, right? And it says brightness and temperature have changed dramatically, but actually I don't find the answer there. And this is a tricky one. When you're mapping, you may not get it right away. But if you read it, you might find this one easier. And I'm not even sure. This one's kind of a tricky one. You actually find it down here in line 45. And it says the smoke absorbs the star's radiating heat and periodically obscures the visible light it emits. So the answer is C, smoke sometimes obscures the star's light. That's something you might read past and not notice. In mapping, you would definitely perhaps had trouble. What we did actually, no, we didn't read that. That comes before the line we even mapped. So that's a tricky one. If you're mapping and reading, it's still kind of a tricky question. Okay, 35. According to the passage, compared to the temperature of the core of a star undergoing nuclear fission, the temperature of carbon dust from the surface is, and we mapped this one right here, and it says the temperature in the stellar core can fluctuate mildly, and sometimes spike as high as tens of millions of degrees. You got to think about the order in which you're thinking about these. So compared to a star undergoing nuclear fission, the temperature of carbon dust is, you might get this one right by thinking about it in the reverse order, or you could find the actual stated here. It's roughly hot enough to melt aluminum, but substantially cooler than the core of any star undergoing nuclear fusion. So your answer is going to be much cooler. And you could have gotten this answer, I think, from either place. It's just, can you think through it to get there if you did where we mapped it? Okay, 36. The passage states that when studying the wind powered by FG Sagittae, Gert's team used the measured amount of emitted infrared radiation to estimate the, okay, so Gert's team we found down here, right? This is the team of Gert's, but the answer we're actually going to find over here around line 70. And so this talks about Gert's team. You got to keep reading. You know where to start with the reading. But we're going to come over, and you don't get to line 70. And it's a pretty straightforward, the amount of stellar material carried away from Sagittaea each second. So it's directly from the text, and the passage states, you know it's there. You just have to find it. 37, based on the passage, FG Sagittaea's efforts to restart nuclear fission would best be characterized as, well, it's not impossible necessarily. So we could eliminate D, although that would be the second choice, I think. But it says, as with an old grease-choked engine struggling to start back up, the star's effort to restart nuclear fission create puffs of thick smoke. So it's labored, right? It's troublesome. It's ultimately not going to work necessarily. So it's labored, and I guess ultimately it's going to die. So that's why D would be the second best choice, and actually it's a choice I know many students make on this one is choice D. But you get it in lines 39 to 41. All right, according to the passage, Gert's research team used infrared light to study FG Sagittaea because infrared light allowed the team to do what? So we mapped it over here on 45 to see through the haze and examine the goings-on near the star surface, view the activity close to the surface. So H, that one's pretty straightforward. It's in the passage. You just have to find it, and we mapped that one. 39, at the end of the passage, the author muses that current regeneration may eventually result in, right? So we have it here, and we mapped it, and I Google summarized as death and rebirth. So if we're doing death and rebirth, might have new and distant Earth, so the formation of new life, A. And 40, according to the passage, if theoretical models are accurate, the stellar renaissance will last for a period best described as. We mapped that one over here around line 25. Without a substantial fuel source to sustain fusion, a nuclear reignition of this kind runs out of gas within a few centuries. So a few centuries are a few hundred years. You have to have that knowledge of what a century is. So F. So this is natural science is the tricky one, remember. If you mapped it, you probably would have missed a couple. Maybe three, but it's better than missing all of them because you're running out of time. Google summary and answer, you still might miss a few. The purpose of Google summary is to know where to look, but you still might have trouble finding one or two. Of course, read and answer is the best strategy, but you have a time issue on science. So practice to figure out which strategies work best for you.